Okay, so this video is to help us with the third rock from the sun exercise. I know there's been a lot of confusion and some questions on this, so I hope this video helps. And I hope you can see my board. I've tried different lighting configurations in the room, and I know it's not the greatest. In fact, I might turn the light down slightly. Maybe it'll help. But we're gonna see how this video goes. So to start off with the third rock from the sun exercise, the whole reason we're doing this exercise we're using the angle of the sun to determine our location, okay? So before there were readily good maps available, you know, sailors, traders, ocean going people, they had to know where they were at, okay? And one way they figured out where they were at, you know, they could use a sundial, let's say, but even before a sundial, is what they would do is they would measure the angle of the sun as it changed as they were sailing, okay? And to help with knowing, and all of this is to find your latitude. Longitude is a different story, which we'll talk about here in a second. But this is all to find your latitude, okay? And to find your latitude, you have to know some things about the Earth and its relation to the sun, okay? So I've drew a sun over here on the board. Hopefully you can see that. It's just a picture of a half sun. And then I've got the Earth here, okay? Now, some people have asked, why is the sun in my examples or on the exercise always on the left-hand side? It doesn't have to be. You could do this exercise with the sun on the right-hand side. It's just, there's no really good answer for that other than just convenience. I'm always drawing the sun on the left, okay? I mean, we all know the Earth goes around the sun, right? And the Earth is tilted at 23.5 degrees, okay? This is just simply the best way to draw the Earth-Sun relationship in a two-dimensional way on a board, okay? So here we go. First of all, the relationship of the Earth to the sun is like this, okay, is in this manner when this would be when in September 21st and March 21st, okay? During those times, we know we have equal daylight and 12 hours of daylight, 12 hours of night, okay? During that period of time, and coincidentally, tomorrow is September 21st, so this exercise is pretty relevant to the time of year that it is. But during these two dates, this is the relationship of the Earth to the sun, okay? So where is our vertical rays? And again, this is at noon, okay? Our vertical rays, so where the sun's rays hit the Earth and make it a 90-degree angle with the surface of the Earth, right here. These are our vertical rays, okay? Our tangent rays are going to be at the Tropic of Cancer and Tropic of Capricorn, okay? Tangent rays. And excuse me, I already made a mistake on that. These are not our tangent rays. These are our oblique rays. Okay, oblique. So hitting the surface of the earth at an angle. Oblique rays. Okay. Our tangent rays, so where the sun's rays are barely touching the surface of the earth, right? That's going to be down here at the South Pole and at the North Pole. These are our tangent rays. Okay, sun's rays barely skim the surface of the earth. South Pole, North Pole, okay? The circle illumination, again, what the circle illumination is going to look like, again, that's telling us where it's daylight and where it's night, okay? The circle of illumination is going to be drawn from the North Pole down to the South Pole, again, because we have 12 hours of daylight, 12 hours of night, right? Equal. That's why this is called the fall equinox, spring equinox. So this side of the earth, nighttime, this side of the earth, daytime, okay? Hopefully that makes sense. September 21st, March 21st, okay? Equal day, equal night, spring and fall equinox, okay? Here in a second, I'm going to pause the video and I'm going to draw up what the circle of illumination looks like in the winter solstice and summer solstice. So I'm going to pause the video and I'll be right back. Okay. Fast forward. We just did the Earth Sun relationship during the spring and fall equinox. Okay, let's fast forward to June 21st, which is the summer solstice. Now, all of these figures that I'm drawing up, this is for if you are in the northern hemisphere, right? All of this is backwards if you're in the southern hemisphere. I don't think anyone in the class is from south of the equator. If you are, then you're going to have to think backwards. But again, in the northern hemisphere, June 21st. So remember, that is our longest day of the year, right? We have more daylight than we do night. Okay, June 21st. So let's look at where the relationship of the earth, what the earth is to the sun on that day. Now I have the earth tilted more towards the sun. Hopefully you can see that. I have the earth tilted more towards the sun. And in the northern hemisphere, that's why we have more daylight. Okay. So where are the vertical rays on June 21st? They are no longer at the equator, right? They are at the Tropic of Cancer. Our vertical rays are now at the Tropic of Cancer. Okay. Where are oblique rays? Oblique rays are like at this side of the Arctic. Oblique rays are hitting the equator now. Okay. Where are our tangent rays? Our tangent rays are now on the back side of the Arctic. Okay, the back side of the Arctic Circle. Okay. Tangent rays, back side of the Arctic Circle. And now the tangent rays in the south are on the front side of the Antarctic Circle, okay? The front side, okay? I don't think my camera is moving down there, but again, the front side, okay? So where is our circle of illumination now? It goes from the back side of the Arctic to the front side of the Antarctic, which makes sense, right? June 21st, has anyone ever been to Alaska? During that time, for example, it rarely ever, it doesn't get nighttime in Alaska. It might get a little dusky like it's evening, but that's the most nighttime you're gonna get, right? Look at our circle of illumination. The whole part of the North Pole is getting sunlight, okay? What happens in the South Pole? We don't get any daylight there, right? If you're in the South Pole on June 21st, it's going to be 24/7 nighttime, okay? So circle of illumination, this part of the earth, night. This part, daylight, okay? All right, hopefully that makes sense. Now I'm not gonna do it for December 21st, which is the winter solstice. Based on these two examples I've just done, you should be able to draw the sun-earth relationship for December 21st, right? The winter solstice. Now that you've seen the summer solstice, it's going to be opposite, right? We are going to have less light. Therefore, the northern hemisphere is going to be tilted away from the sun, okay? So where do you think our circle of illumination is going to be in the winter solstice? It's going to be from the front side of the North Pole to the back side of the South Pole, okay? And that makes sense, right? If you've been to Alaska on December 21st, it's always nighttime there. Never gets, it doesn't get very much daylight. You might get a smattering of it early in the morning, but that's it, okay? So based on this example, I think you should be able to draw the sun-earth relationship for the winter solstice, okay? All right. The next video we're gonna look at is how we get our location, okay? How we get our location using examples like this and knowing the angle of the sun, okay?